people are scrolling or doing something else. LinkedIn, all these applications are running on cloud environment. So that the actual success of cloud computing. Now, moving forward, there are many applications that we see have come across where there is a shift and also technology. Earlier, what we call virtual machine, VM. So this is virtual machine. Virtual machine, we're running on a physical machine. Okay, this is a physical server, physical machine to offer services. Now there is a shift from physical server to containers and microservices to help better software engineer applications. Also, not only computer virtualization, there is something called network virtualization through software-defined networks. Plus, we also have a new technology called blockchain. As you all know, blockchain is primarily associated with offering digital currency like bitcoins. The same blockchain technology can also be used for offering trustable services to end users. So then AI. Now these days, a huge demand for supporting applications, and they are being run on cloud. AI applications have got very unique characteristics. So therefore, we need to extend the cloud to support AI applications. So given these technology trends and the requirements, now let us take a look at how does they impact on the architecture of cloud computing. That brings to micro-tenant clouds. Here you see we have many servers that are interconnected. Okay, these are interconnected. SDN. And also we have containers. So these containers are the ones which can host microservices. So given that is the underlying infrastructure, at the top we have users. So users have certain requirement, expectation of quality, or if they need an infrastructure service, they might say, I want a compute capability with 2 gigahertz of processing power, 1 GB of memory. So such requirements come in. To meet the requirement in cloud environment, what we create is a virtual machine, the foundation. So no server is named after the user. So when you come to access the service, you need to define and then allocate a virtual machine. And this virtual machine has to be physically mapped to a physical machine. So here you see, you can map it to a physical machine. And application is running on it. At some point, number of users can increase. The number of users increase tenfold. If you continue to offer service using whatever you provisioned, they will be very slow. What do? We can dynamically provision extra resource from one or more geographically distributed cloud environments. Today, in this conference, we have many visitors across India, and we also have, for example, I am joining from Australia. Now, to provide us the best interaction for us, so they are what is called as dynamic provisioning. In this case, my request up to a virtual machine running in Australia. Others can be put in different place. And when the demand decreases, you reduce number of resources that are allocated to the cloud environment. So this property of cloud is called elasticity. So therefore, some people call it as a elastic computing. By going for this model, you can use resources efficiently. That is, you rent what you need and how long you need it. And you can also reduce the cost of services. Third, you can minimize the amount of energy consumed by all these scenarios or resources. And as I said, that way we can use efficiently. Now, this requires you a special way of constructing application. Those are called cloud enabling application. So here is one technology called Aneka, which supports creation of such elastic applications. Once you build those applications, you can deploy on private or public cloud in seamless manner. Today we talk about AI. I will discuss about some of the extensions in Aneka to support AI-based applications. So this Aneka comes with two key components. The first one is SDK, software development kit. The second one is runtime machinery. This software development kit contains various application interfaces to support programming of systems using thread model programming, task model programming, MapReduce. And then once you build your application, you can deploy on either on a private cloud or public cloud in a seamless manner. On the last day, we have Dr. Raghavendra from ISRO presenting to you Aneka programming. So he is right. So once you program, you can deploy on private or public cloud. So this feature of Aneka, what we call, is a world-first platform supporting multiple mode of programming. Is very unique. And when we go deep inside Aneka, what we have a container architecture that hosts multiple services, because of which we are able to create thread model, task model, MapReduce in a seamless manner, and then deploy that application on private or public cloud. So this is the Aneka's unique idea. Is patented. We have a US, Australian, and Indian grant also on it. So recently, we licensed to several companies, IT companies, through EST, so that it is benefiting large number of users. So when we deploy this Aneka cloud environment, so you are provisioning, or in a private cloud, you are allocating set of resources. So here you see we allocated different computations where Aneka work is running. And here is Aneka master scaler. So and then here are the users, and users need to build application first. And you can see the users build a task which they want to run across multiple scenarios. First you build a task, then you want to run that scenario analysis, a number of tasks, and that's what is defined here. Task, and each task takes some parameter, and that way we can have a number of tasks running in parallel across multiple servers that are provisioned in this cloud environment. Now, so application that you create, you can deploy across multiple, not only multiple servers in a given data center, cloud data center, but also multiple service providers. So each of these cloud service providers have their own access interface. Microsoft, IBM, Google, and they are listed here. So we have various plugins to support these different cloud service providers. As you know, each cloud service provider has their own access interface. The interface that works on OpenStack infrastructure service plugin are that different from others. So therefore, Aneka has plugins for different capabilities. So this way you can build your application at once and deploy across multiple servers. So as a result, once you build your application, you can deploy on Azure, Amazon, then other cloud, seamless manner. So this Aneka technology has been used by many users worldwide. China Railways Corporation, they are using it for high-speed train design. ISRO, Indian Space Research Organization, they are using it for satellite data processing. Washington State University, they are using it for medical data analytics on cloud. When you are doing medical data analytics, you have privacy requirement. So any data set that have privacy requirement and sensitivity, you don't use public or other purpose. And then we also have other applications such as healthcare, deep learning for object detection, then also COVID-19, open research data set challenge called COVID-19. So these are different applications that there is Anika. Now let us take a look at each of those. Okay, from China Railways Corporation. And here you see they have different train design scenarios. You need to find out one which is the best scenario for your requirement. For that purpose, they use this Maya software, and they used to run on this single focus server that was taking anywhere between 24 hours to 80 hours. And we have set up a design, a private cloud, enterprise cloud using Aneka. And we have a tool called Design Explorer. So this Design Explorer is able to take existing Maya software, run across multiple servers with different image scenarios. As a result, what took 80 hours to do, the same thing they were able to do it in 2 hours. This is a huge discovery or enabling time discovery. And you can see here that 2 hours done. Now you might say, sometimes there's a urgency. The design is taking 2 hours, but your local resource takes 2 hours. Your local resource is not sufficient. What do? We can rent extra resource from a public cloud. So within Aneka, very easy. You can set deadline equal to 10 minutes. Okay. Now I'm renting extra resource from public cloud. I need to pay for it. What can I do? I can set a budget limit. Then I can say budget is equal to RS 50 rupees. Correct? Set a deadline and budget. The system on your behalf is able to identify resources, rent required resources, and then use them and deliver results within the deadline of 10 minutes. This is like utility service. Like, for example, if you want to fly from New Delhi to Hyderabad, you want to come from Delhi to Hyderabad. How can you come? You can come by train, you can come by bus, you can come by flight, or you can come by walk. Each of these pathways have different price as well. If it is urgency, if you need to come within 4 hours, you take aeroplane and then come here. That may be 10,000 rupees. But if it is time is not a problem, you can take an Indian train, come to Hyderabad from Delhi, but you may spend only 400, 500 rupees. So depending upon your requirement of QoS, you select the right one. Similarly, in cloud computing also, depending upon your deadline and budget requirement, the system is able to select the right set of resources. This is the unique approach that we have. No other technology has it. Next, coming to ISRO, Indian Space Research Organization. So ISRO, as you know, different satellites are launched, and data comes to receiving station after monitoring. Then comes to a storage layer where data is stored, and here is the disaster management application they're running, composed using Aneka, running on cloud, and able to do the same thing at lower cost. So you can use the local resource or remote resource seamlessly. And this is something actually done by Raghavendra, who will be presenting Aneka programming on Friday, I think. So next, healthcare application. So in case of healthcare, you have what we call sensors, like body rate sensors that monitor your data. And the monitor data can come to mobile phone. From there, you send it to a mobile phone where processing is done. And then after processing, results come back to end user. Here, why do we need cloud? Cloud we need it because number of users is very large. When many requests are coming with different requirements, the system is able to allocate in such a way that they all are met. This we have shown practically demonstrated. Here you see a sensor to this end. From there, data sent to mobile phone. And from there, we send it to a remote cloud where data is being analyzed. And after analysis, the results are sent back, and you can see the graph on this mobile phone. Just by looking at the graph, you can tell a lot about person health status and how to take care better. And then you will see that was the healthcare. Next is AI application cloud. One of the first prominent application AI is deep learning. In deep learning, so like you got different images, you process them. The deep learning, you can identify what are objects are there in that image. And here you can see this input, and here you see different keyboard, mouse, and so on. And real-time processing of this, to process in real time. So we had to create this program, deep learning program. There's a program called deep.py. Deep.py. It's a Python program. We cloud enabled it. That means we run this program across multiple scenarios or multiple workers, computer engines that are rented. This way we can perform object detection very rapidly. Don't have to wait too long. This is deep learning. Next is machine learning. Machine learning is another approach technique of AI. So as you know, during the last 18 months or 2 years, more than 500,000 papers are published in the context of COVID. If you look for what is the progress in vaccine, which vaccine is more suitable for our scenario. So such a discovery search can take several minutes on a single desktop computer, but you want to do it in a timely manner, real time. For that purpose, we need a machine learning application running on a cloud. So this is a COVID data, and data in brought it, and here multiple workers running on Aneka worker, and then we can present post processing. You can see this is a unique approach that we follow. And then here you see the application that ran. It almost took 20-25 minutes to perform that in a single server. The same thing was done on Singapore server. That took just 5 minutes. Okay, so this way you can reduce time to discovery. This Aneka technology is commercialized through Microsoft. As Professor Kashi Viswanath said, you can download this Aneka from here. Aneka, we now have Aneka 5.0, 5th edition. Aneka, you can download and explore. And so this Aneka is, many users across India are using it for different purposes. For education, for example, and you see numerous universities across India are teaching cloud computing subject, and many of them have set up Aneka based lab and teaching cloud computing courses. And you can see, so we have Aneka set up all the way from Kashmir, Kanyakumari to Kashmir, and then from Maharashtra to Meghalaya. Okay, many places are teaching cloud computing, and many, NITs, many premier institutes in Karnataka and around the world are also using Aneka for teaching cloud computing subject using Aneka. That was on cloud. So about Aneka hands-on experience or demonstrations are scheduled on the last day. Dr. Raghavendra Kune from ISRO will present those things. You can see in action. Coming to next, IoT, Internet of Things, and connecting it to cloud, connecting it to ads. So Internet of Things, what is this Internet of Things? Usually we know Internet, that is networks and networks of computers. Now Internet of Things is taking concept of Internet to everything. For example, let's say this becomes part of Internet. Maybe inside there will be water sensor. From my mobile, I get a notification, oh, you are running out of water in the bottle. Then I can ask somebody to fill, keep ready so that when I am giving talk, I can drink. And trees, the lighting systems, signaling systems, they all become part of network. As a result, we can create smart world. Means we can make home smarter, healthcare, taking care better, like this watch with sensor, monitor your activity, health activity, and take care of better. Then smart transport systems, agriculture using water resource efficiently for irrigation. Then advanced manufacturing, also smart grid. Like this, different applications can be created where physical and digital world brought together in seamless manner through IoT, through mobility, through cloud. Create interesting applications. To support these IoT applications, we need new computing paradigms. And what are those? So that's what we call edge-giant cloud computing, edge-giant fog computing. The first generation IoT applications are cloud-centric. You can see these are the IoT applications. First generations are using cloud as a way for processing the data generated by IoT. And after that, the results are sent back to end users. Of course, this is a successful model, but by 2030, you will see billions of objects being part of internet, or maybe trillions. If all of this push data to the remote cloud through internet, what happens? Internet traffic will be very high. It will be just like Bangalore or Hyderabad traffic during peak hours. You go from house to office 10 kilometers, but it will take 2 hours. So same problem here. Low bandwidth plus latency will be high. To overcome that limitation, the new idea is to use resource at the edge of the network. This is like working from home. You don't waste, you don't go to office spending some of the time. So instead, you can do it from home. So that is what this conference is doing. You are located in different places and able to join this event easily. Then there is something called fog computing that not only uses edge but also uses core network or the remote cloud. It is called fog computing. So these are the 3 different models of computing to support IoT applications. In this direction, so we developed a Fogbus lightweight software framework to support edge and for computing applications. This also comes with blockchain. What is this blockchain? As you know, it's a blockchain paradigm for digital currency, but you can also use blockchain for creating trustable services. So here is the fog bus we developed. This is the device. The device can talk to an app, which we call gateway running, and then that can send you to a Focus master server. The master can manage multiple small, tiny compute devices such as Raspberry Pi, where processing is done. Sometimes you need extra resource, that time you use this public cloud like Azure together and enable many applications. One such prominent application is healthcare. So healthcare is making a big wave through IoT and applications such as remote health monitoring and health system management. In case of remote health monitoring, you have many things that you want to monitor, such as ECG, blood pressure, glucose, temperature, oxygen saturation, and so on. And from this, you see how person is doing. Are they healthy? For example, if a person has a COVID symptom, isolated at home, we need to know how a person is actually progressing. Is he recovering or is it something serious? You can do that remotely through device and then data processing in Azure cloud. And we have built such an environment for sleep apnea analysis application. This is the ECG device. Collect the data. This is the app we developed, healthcare app. And this app takes the data and send it to the edge and cloud environment to processing. After processing, the results are presented, and here you see the status of the results. The severity of the disease can be normal, can be mild, can be emergency. And based on situation, person need to be taken care. We have shown this demo also many places. Here you see we connected the oximeter to the finger, small device, and then data collected and processed on this edge oximeter, Raspberry Pis, sometime on public cloud. So this way you can support interesting application to make impact in the environment. The next application is drones. As you all know, so drones have become very popular these days, but drones can also be put in for better use. During lockdown earlier throughout India and of course worldwide, the big cities like Noida, that near Delhi, their multi-story buildings are there. The lockdown, so many people in the multi-story building. If you want to see how everybody is doing, so we took a drone, multiple drones, a drone fitted with thermal camera like this. Then people were asked to come to balcony, and the drone is able to go around the building to see if anybody has a temperature or a symptom like what we see in one who is COVID positive. Then person can be isolated. So here is what we did. These are the drones. Thermal camera measuring body temperature, sending the data edge for processing, then of course then produce a result. So this is the work that we have done in the context of COVID-19 pandemic, how to combat it. Okay, that was about edge cloud for IoT and enterprise healthcare applications. Now let's take a look at quantum. Quantum computing is another very hot area right now. As I told you, quantum computing in binary computer, digital computers, we have got 0 or 1, correct? In quantum, you got n bits. Instead of binary, there is 2, you will have n bits like this. This is representing the state. In this case, you got around 12 bits quantum computer. Here you can see, the quantum processing, you can have the 12 number of states, means processing can be done faster. There are problems which you can solve, big problems. So that is another big area. So this quantum programming is actually very hard. So if you look at computing science 50 years ago and how they used to program using punch card, correct? Punch card, you used to punch, then there is a program, you feed it to your mainframe, that processes, after 2 days you get a result. Similarly, in the programming in quantum computing, the programming is through gates. You define n number of bits, correct? Then you can, on this line, you can put different gates. That becomes a program. So this is the quantum circuitry for random number generation. This is a very low level programming. On top of it, even if you use high level expression, and they are also very complex. You see here, this is for IBM, Qiskit, then Microsoft, Q-Sharp, like that. This is very complex programming. So to enhance the software programming, we built this QFAS, Quantum Serverless Functional Service, for quantum computing. Using this, you can simplify application development, manage the process better. You can use multiple clouds because each cloud offering different quantum services, put them together. So this is the system that we developed. And here you see, so when the comes, the system can check what kind of function it is. Is it classical? Is it hybrid? Is it quantum? If it is quantum, process on a quantum node, otherwise you process on a standard CPU. So this is a very unique technology we developed. So this is gaining also popularity. So in order to support applications. So with that, let me conclude. I want to actually give more time for question answer because you will hear more of specific things with depth in the next days, following days. To summarize, there are several computing paradigms that have promised the vision of how to make computing as utility. Today, we have cloud computing that made this vision into reality. And cloud offers many applications already running on cloud. And of course, moving forward, AI, IoT, and all. And to build those applications, you can build many ways. Aneka is one of the technology you can use to build software rapidly, where you can enhance the software engineering with minimal time and minimal cost. And we saw many applications of Aneka supporting different areas from different countries around the world, and also people using it for teaching. And then this IoT, Internet of Things, the first generation IoT was a cloud-centric. The new generation IoT, as we move forward, are going to be edge or fog-centric. Thus, we can reduce load on internet and support real-time IoT applications. Now that quantum hardware is slowly appearing, so therefore people are making it available through clouds. Hence, we can also make this application engineering easier, wherein classical application, quantum code can be put together and nicely. That is what this technology we developed. In terms of future directions, there are many open areas. Here is a manifesto that defines the directions. You probably hear this word manifesto in the context of elections in India. Whenever there is a central government election or state elections, these political parties come with manifesto promising, we do these things during next 5 years. Correct? So like Modi ji said, other people say, okay, free electricity, free cloud computing, free food, free healthcare, free education. Like that, they all promise. That's a manifesto. May not fulfill. Here is a similar manifesto we put together for cloud computing, but our manifesto is real. So here we identify many open challenges and define future direction, research direction that you all can read and go through. There are many open areas in security area, in resource management area, in application programming area, in high performance computing. Like this, we identified, and you can go through. These areas are defined by experts around the world, work together and defined different functions. If you want to learn more about cloud computing, here's the book Mastering Cloud Computing, American edition. It might cost almost $100, too costly for our India. Don't worry. We have an India solution, or Make in India, published by McGraw-Hill in Delhi. So this book is now available for a small price. For Indian market, almost $8. Very affordable. The same book is also available in Chinese. We can't forget them. Sometimes we say China, India, why? So let's give them a book. So this book for them is $3. People often ask me why Chinese is so low cost. Usually we think it should be half price of India, say $4, but it is $3. Why? It's mainly because the print in Chinese, you see here Mastering Cloud Computing, this title. In English, it is 2 lines. The same thing in Chinese font, it is only 1 line, like a noodle, they put together in just compact. The book, this is 500 pages book, okay? When you print in Chinese, it is 300 pages because of compact one. It should have been 250, but it is 300 pages because programs in Aneka programming are still in English. The rest of the tasks are in Chinese. That's why it's like that. Okay. And what I'm also highlighting is that when you build cloud services, say healthcare services, and you make it available to citizens of India, the price that you charge can be based on the people affordability and where they're coming from. If they are in from major cities like Delhi, Bangalore, and Hyderabad or Mumbai, you can charge them a bit more higher price, something like 100 rupees per request. But if the same request is coming from small villages, you charge them just 1 rupee or 2 rupees. Make it affordable. Okay, that's important. So this is something to keep in mind if you're going to be a future entrepreneur of certain cloud-based services to support individuals. So IoT, there are dedicated books too. So here is one I did. And also edge computing, also dedicated books. You can read them to understand more concepts, then put in practice. With that, let me thank all of you for your attentive here. I see through direct this GoToMeeting, more than 250 participants still there. And I also heard that there are many who are joining online through, I think, YouTube or Facebook, some streaming. It seems I was told that 3,000 or something like that registered. This GoToMeeting can only support first 260 participants. The remaining have to go that way. So thank you all for hearing. Here are my contacts. If you want to collaborate, YouTube channel. So this is my University of Melbourne email ID for research. Or you want to study here, you can apply. Contact me through rboy@unimal.edu. If you want to set up a cloud lab at your university institute or want to do some interesting application, you can contact me using raj@manjurosab.com. That's email ID. Okay, so I hope there are a large number of participants on the YouTube channel. That's good. But you all can type a question. So I will be happy to answer them. Thank you very much.
Are there any questions? If there are any questions,
so you can even type the question in the chat box.
You can yourself.
Sir, good. This is Dr. Nandu. Can you?
You put them in the chat box.
Yeah. So my question is, can you give some example for quantum computing along with parallel computing?
Okay.
How? Yeah.
So you can say in quantum computing, we are doing parallel processing. So usually parallel processing, we are doing on a multi-core machines or supercomputers, correct?
Yeah.
Now quantum computing likes supercomputing or parallel processing. So the classical system so far were operating based on these binary bits, correct? Digital computers.
Yeah. Yeah. Yeah.
In quantum, you got n bits, not just 2
Okay.
bits, n number of bits. N can be 10, 20, 30, 1000, correct?
Yeah.
Right now, these are promise. People say in by 2030 we'll have huge number of qubits. So IBM recently announced, I think 300 something. So because of this n number of bits through quantum mechanics principle, they do so many operations at the same time. That means if supercomputer takes 1 day to process, maybe quantum-based system can do it in 1 minute. Yeah. So that means there is a big worry also. The worry is, for example, security. This security keys, our public key, private key, cryptography that we use in our digital computer to secure our systems. Maybe people who want to hack, they can use quantum computer to do it faster, quickly. There is worry anyway. But anyway, there are a number of problems such as drug discovery. So during this pandemic, the first 1 year we didn't have any vaccine, correct?
Yeah. Yeah.
It took, first you have to find out the protein structure of that virus. Then after that, you have to find out suitable drugs that can do proper binding. That is called molecular docking for drug discovery. So all this through the racing, everybody is investing, and somehow they come out with some vaccine, working, not working, whatever. But in 1.5 year time, they have done it.
Yeah.
Correct? With biologically, we can do the same thing in 6 months' time. Drug discovery. And next is investment risk analysis. So there are applications that takes several days to do, or even the weather forecasting. So right now, weather forecasting is very much coarse grain. They will tell you there may be heavy rain in Hyderabad, heavy rain in Delhi, like the high level they tell you. But they don't tell you precisely, will there be rain on my house?
Yeah.
In my colony, I am planning a wedding. I want to pick up a date and time so that there is no rain in my place. So that level of microscopic weather forecasting, the today's system, they don't do it because it takes too much of time to forecast. With quantum, perhaps you can. So these are more of futuristic applications that are, promised with quantum computing. And as usual, as you know, our computing science people keep inventing new hardware, new software. But of course, software array is very, very weak. As I said, quantum programming today is very much like programming computers in 1960. 1960s with punch card. You heard about punch card? Yeah.
Even
most of us have not seen. Correct? Most of us have not seen. I'm sure. All those attending today, they have not seen.
punch card, yes, in Fortran 2 and Fortran 4.
Yes. Yeah. And also, if you're doing digital circuitry lab, you take a small test bed and then you take AND gate, OR gate, you put them together to create a multiplier, whatever, like this. Very basic. So quantum programming is like that, very basic level. So we need to advance the software of quantum programming, so thereby we can make it more easy to program. And that is our focus at this moment. I mentioned very briefly about that QFAS. That is the first, some of the steps to the direction. So having said that, as I told you, people are building very specific quantum security for different common, like if you have got some application, there are 200 libraries that are very common across all scientific applications. What can you do? You can create those quantum enabled, even if it is hard to program, you create them and then build for those applications. So that is the today's state of. So in simple term, quantum computing is like a parallel processing, but in n dimensions. Okay.
What type of the hardware is expected to be tried to implement quantum computing.
Yeah, they're building their own hardware. I don't have much experience with hardware, but quantum hardware, based on this quantum mechanics principles, people are building. In Australia, there is so much of investment on quantum hardware development.
Okay.
And IBM also built one like that. Google also did something. Microsoft is doing. Amazon is doing. Everyone is trying to do quantum hardware.
Okay. It's a multi-core system or only.
Different. They have their own. It's very much look like right now. It looks like a big factory.
Okay.
Yeah. So can I get quantum processor in my laptop? Maybe 10, 20 year time.
Okay.
Just like GPU. You heard about GPU?
Yeah.
GPUs, if you ask 15 years ago, yes, GPUs were there in supercomputers.
Yeah.
But they were too expensive to have it on mobile phone, on laptops. But now GPUs are mobile phone, GPUs are laptop also. So same thing. There are lots of temperature constraints, physical system constraints. So over a period of time, they all become simple, easy. Yeah. So, but having said that, they are now made available through cloud access for selected people. So we all have access through Melbourne University. So we build the software to showcase the future of how we need advanced software area.
Okay, sir. Thank you. Very nice explanation. Thank you. Thank you, sir.
Any other question?
Participants are requested to ask the queries to the resource person, Dr. Rajkumar Boya, sir.
Good morning, sir.
Yes.
Sir, is there any procedure to set a cloud lab in our campus? That is, I'm in engineering institute. So, what is the procedure and what is the cost it requires?
Yes, very good. So one for say in engineering colleges, in terms of hardware, you already have many PCs running Windows, and they are already LAN connected. Okay, so we can use that hardware to start with, where this Aneka software can be installed on some PCs, Aneka master, many others, Aneka workers. Then you create a small cloud lab, and you can use it for teaching the subject on say cloud application programming. For that, we have this mastering cloud computing book and also PowerPoint slides, and we also supply various lab examples that you can use for mounting practical subject as well. That's one way. Some others are also setting up a dedicated facility. Some of them want to create a small private cloud by having a couple of servers put together, put Aneka and few other software on top of it. And other third type of people are also creating a dedicated PC lab with cloud computing. Like that, different people are using. So given hardware is available, all you need to do is you can just buy our software Aneka. So you can send me an email. So our people can help you on what is the process involved in procuring. Then we come and help set up, and we give training to teachers so that they can next introduce and teach other students, use it for research and so on.
Okay, thank you, sir.
We try to make it as affordable depending on college and so on.
Okay, thank you, sir.
Yeah, please send me email. Raj@mandrasab.com.
Now I request any other participant. Now request any other participants to ask for the queries.
Sir, can you hear me? Hello, can you hear me, sir?
Yeah, so far what we discussed were the practical things, but we can also do modeling and simulation. For that purpose, for cloud computing, so we have Cloud Sim. So those who are working in cloud computing, you will know about the software. Cloud Sim is a simulator, discrete event simulation software that one can use for modeling and simulation. We can do that on your just laptop. And for edge and for computing for our application, we have something called iFoxing. Okay. These two simulators are used by researchers around the world. Already more than 7,000 research papers are published by researchers around the world, including many companies. Companies use it for their modeling and simulation design, modeling of their data centers before they build a real one. That is modeling and simulation. Of course, the practical is always a good idea. If you have got good hands-on experience, then you can do better modeling and simulation. For students, if you are graduating many students like BTech, MTech, masters, bachelors, so if they have skills in cloud application programming, so those skills are of high demand in industrial world.
Sir, can you hear me, sir? I have a question.
If anybody, any of you are planning to, want to have hands-on experience, maybe let me provide. I think I requested Professor Kasi to share with all of you. So we have, so there are universities in Kolhapur. They have a 2-day international workshop on edge and cloud computing, where full day there will be hands-on training, programming. So that is one place to come. If you are here, Kanyakumari in Kerala or in Trivandrum, or in Tamil Nadu is a place. If you want to come to Kanyakumari, there is a university called Joy University. So they have organized. You can come there for more hands-on experience. So I will request Professor Kasi to share
Yes.
links to this.
Definitely, sir, because we have created so many WhatsApp groups for these numbers. We'll post
Yes,
in that group.
please post.
Right,
So
sir.
those who want some more hands-on, want to spend some time programming, and of course you can also come if you come to Kolhapur. Kolhapur, as you know, is the biggest temple, Mahalakshmi. All those who are visited Tirupati, if you want your visit to be 100% complete, then you also have to visit Mahalakshmi in Kolhapur. And you get the knowledge, then also get some blessing from Mahalakshmi, then get more Lakshmi later.
Okay, sir, definitely.
Yeah. Otherwise, you want to see this Kanyakumari, Vivekananda, what did he do there? So this Joy University, come there, and Joy University December 7, soon. So you can give hands-on experience. So people
Any other questions from the
can even have general
participants?
questions. General question research if you like. Don't feel shy.
Participants are requested to ask some more questions so that we'll get some good idea to do research work in cloud computing area. Definitely, Professor sir will elaborate on those. I
Sir,
request
can you
all
hear
the
me?
participants.
Yes, sir, you can proceed.
Yeah,
Okay,
this is
sir,
Dr. Gopal. Sir, can you hear me?
Yes.
Yeah. Can you give some example applications for IoT services, aircraft?
Okay.
Aerospace.
IoT. Okay, good.
Yeah.
So IoT applications. See, these days people talk about healthcare, self-care. So already oximeter have come. In fact, let me see if my student is here. There? No, he's not there. Jayat is there, no?
Hello.
No, don't do it. Okay, I thought of bringing those healthcare devices to show you guys in real. So oximeter, or even like this, they put various medical devices. They are like Internet of Things, medical devices. So these data can be captured you analyze on the computing system. So to see how your health you are doing. So that is the healthcare application, is an application of IoT. Then, for example, smart agriculture. So in smart agriculture, why does it mean smart? So for example, if you got a sugarcane field, so you need to water the plant, irrigation. So people simply just start the motor, then just water is keep going everywhere. You want to use water efficiently. What can you do? You can have a moisture sensor that put in few places. That moisture sensor can see what is the moisture level. Based on that, it can give instruction on whether to water the plants or not. That way, we can save the water. Or moisture sensor can be integrated with the weather forecasting system. Oh, today moisture level is like this. In 2 days' time or 3 days' time, there is heavy rain. Therefore, there is no need of irrigating. By doing this, you can save electricity bill. You can save water. That is smart agriculture. Then smart cities. Smart cities, say for example, Bangalore or Hyderabad. You want to go by walk from your house to the office, but you want to take a path which is less polluted to keep yourself healthy. So this there can be this oxygen sensor deployed different places. This sensor report data to say Google Map. Then from there it can give you a map. Go this way, you will be more healthy. Then in smart city, another area, traffic, managing traffic, traffic light seamlessly. So this can through a camera, they can get images various places. Then they can direct traffic signals in such a way that there will be fast flow. That is part of smart city. So like this, many applications, security application. So everything become part of internet. That's what I mean. Yeah, that is. So even I was giving an example of this. If this has a some kind of water level sensor, so then that can send a messages. So water level is up to here. Then if it knows if that the message is given and I'm going to speak, then they can send a message to somebody else. Oh, here is Bhuya is going to give a speech. Next to that, this bottle is full of water, so they can drink. So this can talk to the system. Like things become part of the network. So applications are endless.
We can do applications in aircraft also, no? Yeah, the cloud traffic, while aircraft is moving in the cloud.
Yes.
Yeah, we can identify where is the more clouds are there, raining is there. This type of
Oh yeah,
application.
then also another one. Of course, aircraft system can have that kind of one. They can tell you too.
Okay.
Yes. So these are some of the example application, where IoT can be used. Basically, Internet of Things. Internet means networks of computers, not just computers being part of Internet, everything being part of Internet. Is that clear? Okay.
Yeah.
Somebody is asking, where is Kolhapur? Very good question. Kolhapur is in Maharashtra. It's private. Vinay Kumar. Vinay is a Ganapati. Correct? Vinay means Vinayaka. Vinay Kumar is asking, where is Kolhapur? Kolhapur is, as I said, in Maharashtra. After Solapur. Ask Google, just say Kolhapur, it will tell you.
If no more questions from the participant side, now I request K.V. Rameshwar Reddy, Associate Professor of CSC Department, to give the closing remarks.
Okay. Good morning, everyone. I'm Rameshwar Reddy, Associate Professor of CSC Department, and I'm very honored and delighted to deliver the closing remarks on the first day session of the one-week faculty development program on cloud computing and its applications, organized by Department of CSC, G. Pullard Engineering College, Autonomous. First of all, I would like to thank Dr. Rajkumar Bhuya, Professor, University of Melbourne, Australia. Professor Rajkumar Bhuya filled with insightful content about cloud computing basics, trends in cloud computing, and architecture of the cloud computing and its applications. And I would like to thank my team to organizing this 1 week FDP and their enthusiastic and dedicated work, while I see that they put their heart and soul to make this event happen. And I'm extremely pleased that the FDP was well attended by various stakeholders ranging from professors, research scholars, and industry practitioners and experts. As this FTP is organized in online mode, there might be some network disturbances that might have crawled unknowingly. I request everyone to turn the blind eye towards them. And thank you.
Thank you, Bhuya sir, for your nice session. Everyone enjoyed.
Full info. Yeah. So yeah, thank you very much. So thank you for inviting. So I'll send you links. You can just forward it to all the people who subscribe, registered for this work. Yeah, actually, you told how many people have joined.
Sure.
Those who registered, I think you had a huge number, right?
In YouTube, almost 400, sir. 400 to 500.
Okay.
It is very.
And the registration was,
and
you were
for
saying?
this, almost 1,000, sir.
Oh, very nice.
Including this.
That's good. Yeah, no, that is actually good recognition for your effort to bring some benefit to the community.
Definitely, sir.
Yeah. No problem. I wish you all the best with everybody, all the best with the rest of the days. I'm still waiting for some period. If anybody want to talk to me.
Any participant want have interaction with Bhuya sir, you are welcome.
Sir, I had a question. Can you hear me?
Yes.
Sir, I wanted to ask, in the company you are running, do you provide off-the-shelf software to companies, or you only provide the cloud infrastructure? And how tough is it to service each, let's say, healthcare client or some other kind of research organizations, because their needs are different? So do you provide off-the-shelf software, or is it just infrastructure where some components are like fixed?
Yes, so good question. We provide off-the-shelf software, and using that software you can set up a cloud facility and build application use it. So Professor Kasi is here. So a couple of years ago, I think several years ago, so he set up a cloud in his department. So there our software was installed and use it. Yeah. And in terms of what is the effort involved in building application. So suppose if you have already an application running on a laptop, right? But you want to make that application to support large number of users. So this is where you can cloud enabling. So cloud enabling using Aneka is very, very easy. For example, if you have a ready-made program already running on your laptop called abc.exe, we can connect cloud enable that abc.exe using Aneka's task model. So when the request comes in, you can farm out those tasks across multiple servers, each running the same program but with different requests, different user requests. Is it clear?
Yes, sir. Kind of clear. Yeah.
Yeah. Such.
And also, do you?
Yeah.
Sorry. Do you have open APIs and open web services also, like running for, let's say, on if it's a platform, whatever you are running, and on top of that, let's say where people are building applications, they can send data and other things through web services or open APIs and so on?
Yes. So, you meant open MP, you mean?
APIs, application programming interface.
Yes, APIs. Within Aneka, we have got primarily multiple APIs, but there are, creating cloud applications, there are programming models. Yeah. So we have task model programming, thread level programming, and MapReduce programming. These are different APIs support within Aneka.
Okay, sir. Okay. Thank you.
Yeah, so that way you can create application very easily.
Okay, sir. Thank you.
Yes, any other questions? So if there are no other questions, thank you very much, everyone. Thank you, sir, Bhuya, sir. So feedback link is being shared with you, as well as it will be available in the WhatsApp link. Everybody is requested to give the feedback to get the certificate at the end. Thank you, sir. Thank you, Bhuya, sir, very much. So tomorrow we will be meeting again at 10 a.m.
Yes.
Thank you. Thank you very much.
All right, wish you all the best. There is a good condition. If you give feedback, then only you get a certificate.
Yes, sir.
All right.
Right, sir. At least to create the seriousness, sir. At least,
Yes. So
right,
that way, so they are given some incentive for helping.
yeah.
All right.
Right, sir. Thank you very much, sir. Yes, sir.
Thank you.
So we'll meet you again. Right, sir.
Sure.